Hello class, this is lesson 3.1. The topic is complex numbers. So before I introduce complex numbers, I want to just talk about numbers for a little bit to motivate why we need complex numbers. So let's start with the most basic type of numbers, which we call the natural numbers. Okay, so the natural numbers are the numbers 1, 2, 3, so on, sort of like the numbers you learn about in Sesame Street, just the whole numbers, no decimals or anything. Well, I mean, technically the decimals are 0.0000, so on, but just the whole numbers. Sometimes they include 0, some books do not. But we will just call the natural numbers 1, 2, 3, and so on. Okay, so they're pretty easy numbers to understand. I think we have sort of always understood these numbers. But eventually we came across problems where these numbers just were not enough. So, like consider the following problem. If x plus 3 equals 0, right? Eventually people started encountering problems like this, even though they maybe didn't have algebra at the time, but they were similar problems like this. And if you just have the natural numbers, it's not enough to solve it. You need negative numbers, right? So then eventually we extended this number system to include 0 and the negative numbers. So we call these numbers the integers. And that's 0, and then we have positive 1 or negative 1, positive 2 or negative 2, etc. Okay, so these numbers are better, but there still is problems where these numbers are not enough. Like, for example, 3x plus 1 equals 0. If we're only using the intervals, we cannot solve this problem. Right, so that's when we needed what is called rational numbers. Right, and then these are the numbers of the form a over b, where a, b are integers. Of course, b is not 0. So now we could solve problems like 3x plus 1 equals 0. But even these numbers were not enough for some problems. You know, we couldn't solve a problem like the circumference of a circle, for example. We could not use a rational number to find 2 pi, which is the circumference of a circle. Right? If we just use rational numbers, we can't find the circumference of a circle. So even the rational numbers were not enough. We had to extend those into what we call the real numbers. Right, the real numbers, which are the numbers we have been using in this class, all the points from minus infinity to infinity. Right, so this includes numbers like pi, for example, which is not a rational. But even these numbers are not enough to solve a problem like x squared plus 1 equals 0. So, following the same trend that we have been, we need to extend the real numbers into what is called the complex numbers. Okay, and now with this number system, we can solve all of the above problems. So, what is a complex number? It is all of the numbers of this form. a plus bi, where I is defined as the square root of negative 1. Okay, so why did we define I as the square root of negative 1? Well, if we look back at this question here, x squared plus 1 equals 0, when we tried to solve it, we get x squared equals negative 1, x equals plus or minus square root of negative 1, which, as we know, there's no real number with this property. Because with real numbers, whenever you square a real number, it's always positive, but that's not the case with complex numbers. So sometimes a complex number squared could be negative. In fact, I squared is negative 1, right? Just square both sides of this definition here. Okay, so that is the definition of complex numbers and a little motivation behind it. And for the rest of this section, we will just practice some examples using complex numbers, and we will learn how to add, subtract, and multiply complex numbers. So for an analogy, when you were younger in school and you started with these numbers, and then you were introduced to fractions, you had to learn a few new rules about fractions and how to add, subtract fractions. So it's the same idea here. Now that we're learning a new number system, we have to learn a few new properties, and then eventually you will get used to it. Okay, so let's begin with some examples now. Okay, so we'll start easy. First, let's just write a number in the complex notation where we use an I. So let's write negative square root of negative 4 in terms of I. So how we do that is we take this number, right, so we could think about it like this. It's like negative 1 times 4 inside of the square root. So we are allowed to do this, break it into 2 square roots, so we have this negative on the outside. And now we also have square root negative 1 and then square root 4. As you know, square root 4 is 2, and square root negative 1 is I, right? So square root 4 is where we get the 2, square root negative 1 is where we get the I, and I had to carry along this minus sign. And now this is in terms of I. Okay, so you'll see a few examples like that in the homework. Should be pretty easy. Let me now explain how we add and subtract complex numbers. So for addition and subtraction, we have the following property. Let's have a plus bi and c plus di be complex numbers. And just let me pause here for a second, give you some more vocab. We call this the real part and this the imaginary part. So the part that's multiplied to an I is the imaginary part, is the word we use, imaginary, and then this is the real part. Now these are just words. It doesn't mean it's imaginary in the everyday English sense of the word imaginary. They just sort of got that name for historical reasons, so don't let that psych you out too much. Anyways, back to the question. So we have 2 complex numbers, and how we add and subtract them is the following property. We do the first number plus the second number, c plus d I equals, what we do is we add the real parts together, so a plus c, and then we add the imaginary parts together and multiply the imaginary part by I. So we do addition component-wise. We add these real components together, and then we add the imaginary components together. Okay, so let me do an example. And if we were doing subtraction, it's the same thing. We just have a minus sign there, so I'll do plus or minus. Okay, and I will give a few examples. So say we have 7 plus 3i plus 6 minus 2i. Now this is pretty easy. It's just like combining like terms pretty much. So in chapter 1 or 2, when we were combining like terms, we would always add the numbers together and then add the other numbers with an x in front of them together. So you could kind of think about this I like a variable in that sense when it's so anyways, here we combine the like terms, so we do 7 plus 6, then we combine all of the terms with an I in it, so 3 plus negative 2 I. Okay, so yeah, now we just crunch the numbers. So we have the 13 plus 3 minus 2 is 1, so 1i. Don't really need to write the 1 in front. It just looks better to do I. Right, you could do 3 minus 2 is 1, but that looks kind of weird, so we usually just write 13 plus I there. Okay. Now let's do an example with subtraction. So say we have 5 plus 2i minus 6 plus I. So here's two complex numbers. If we subtract them, we just subtract the real parts, and we subtract the imaginary parts. Okay, so 5 minus 6, and then 2 minus 1, it's really 1 times I. We just usually don't write the 1, so that's 2 minus 1 for the imaginary part. Okay, so our real part is negative 1. The imaginary part is 1. And that is the answer. Okay. Next, let's look at multiplying some complex numbers. Now for multiplication, it's pretty easy. We just FOIL it out. So if we have a plus bi times c plus d I, what we do is the following. We do this, a times c, and then you do a times di, and then we do b times ci, and then we multiply the last two numbers. So bd times I, or I squared. Okay, but remember, I squared equals negative 1. And if we go back to this definition, I squared equals negative 1. So when we're multiplying out complex numbers, sometimes we get I squared, and we could simplify that. So here we have AC plus AD plus BC, those all have an imaginary part, and we have minus BD. Right, so instead of the I squared, I just wrote a minus sign because I squared equals negative 1. So to further simplify, our real part is AC minus BD. The imaginary part is AD plus BC. Okay, so that's how you multiply two complex numbers. We'll start with some easy examples where the real part is 0. So if we're just multiplying, say, square root of negative 3 times square root of negative 4, well, that's like saying square root of 3i times 2i, which is 2 times square root 3i squared. I squared is negative 1, so that's negative 2 square root 3. Okay, let's look at a little harder one. Let's do 1 plus 2i times 3 minus 4i. So 1 times 3 is 3. 1 times negative 4i is negative 4i. 2i times 3 is 6i. 2i times minus 4i is minus 8i squared. Now we combine the like terms. We have 3 plus 2i, and now I squared equals negative 1, but we already have a negative there, so that will turn into a positive. So we have plus 8. All right, so 11 plus 2i. And this is the standard notation. We like to write the real part plus the imaginary part. So we like our answers to look like this. We want the answers to look like a plus bi. Okay, so maybe I'll do one more multiplication example. Let's look at 2 minus I squared. Well, what that means is we do 2 minus I times itself. Okay, and then we FOIL it out. So we have 4 minus 2i minus 2i plus I squared. We simplify, that's 4 minus 4i, and then I squared really is negative 1, so 3 minus 4i. Okay. Now, last thing I want to talk about is division. And before we get into division, I need to give you a vocab word. Let's see, I'm not sure if I saw any division on the homework, but you may still encounter it in the future, so let's still go over it. Anyways, before I get into division, we need to learn about what is called a conjugate. And it's pretty easy. The conjugate of a plus bi is a minus bi. Okay, so these are conjugates. You just change the symbol in between the real and imaginary part. It's a minus, you change it to a plus sign, and that's the conjugate. Right, so these are conjugates. Let's look at a property of multiplying conjugates together. So if you have a conjugate, say 2 plus I, its conjugate would be 2 minus I. And let's look at what happens when you multiply a complex number with its conjugate. Well, we FOIL this out. That's 4 minus 2I plus 2I minus I squared. So what happened here? This and that cancel out, and that always happens when you multiply by conjugates. The two middle steps will cancel out. And now we have a negative I squared. Right? Negative I squared just equals positive 1. So we end up with 4 plus 1, 5. So what happened when you multiplied by a conjugate is the two imaginary parts canceled out, and we just get this number here. So it's pretty convenient property. The reason why I brought that up is because when we do division, we do it in the following way, and I'm just going to explain how to do a division by an example. So say we want to do 1 minus I divided by 2 plus I. Right? How do we do this? What we do is we multiply the top and bottom by the conjugate of the bottom. So let me write that down because that was a kind of a big sentence here. We multiply the top and bottom by the bottom's conjugate. Okay, so what do I mean by that? Well, we have the following problem we want to solve. 1 minus I divided by 2 plus I. Now the conjugate of the bottom is 2 minus I, so we just multiply that on the top and the bottom. And then let's see what happens. We're going to have to multiply all these out. So if we multiply the top out, we get 2, and then minus I, minus 2I, so minus 3I, and then plus I squared. That's what we get on the top. The bottom we get 4 minus 2I plus 2I, right? Because we're multiplying conjugates, these bottom steps will cancel out. We get minus I squared. So on the top we have 2 minus 3I minus 1, because I squared equals negative 1. And on the bottom we have 4 plus 1, we have 5. Okay, so 1 minus 3I on the top, 5 on the bottom. And now we are done. But we typically like to write it the following way. We like to write the real part and the imaginary part times I. And that is the answer. Okay, so that concludes today's lesson where we introduced complex numbers. Thank you.